Welcome to week 5, new KNEW 11, another review topic, scientific notation. This one, you're going to kind of say like, where does this fit in to this week? While it doesn't completely fit in, it's not going to have like a nice, tidy, neat place in what we're really doing this week. We are kind of coming to a close of the semester, as hard as it is to believe, and this is one of the topics where there is a question or two that ends up being on the final, and it's one of those topics that it's a very doable question, and when you get to it on the final, it's not one that you want to miss. And this topic is literally the topic that somebody, when I first started teaching this course, they were like, and you get to that scientific notation problem and you totally, it's like one of those things that you don't even remember from Algebra 1. So it's always something that I make sure that I review somewhere in the semester, usually towards the end, so that you have the best chance of remembering it. So let's review it a little bit now, and it will be fresh in your mind when you get to that final exam in 2 weeks. So, putting numbers into scientific notation and taking numbers out of scientific notation. The biggest thing about scientific notation, it's just, it's one of those like finicky etiquette things that mathematicians and scientists are known for, like the royal family, which I've referenced a few times. Kind of stuffy, there's rules, there's regulations, there's things that you have to do that there's no rhyme or reason for, other than it's the way it needs to be done or has to be done. So that said, what scientific notation looks like is the number has to be between 1 and 10. Okay? And then it's times, and this kind of goes against every rule that we've had in Algebra 2, because you do use an X. This is multiplication. This is not a variable. Okay, we've used it as a variable the whole time this semester, but we're going to use it as multiplication here. And then it's 10 to an exponent. And that's really the only way it fits into this course and this section this week, because we do touch on exponents in the next video for a quick second again. Now, the way I remember this, if this is a positive exponent, it's a big number. If this is a negative exponent, it's a small number. That means a decimal. That means a large number. And when I mean like large number, like I'm talking like millions, thousands, millions, trillions, that kind of thing. Okay? So let's, I'll show you my method and then we'll practice a couple. So what I mean by this part, the number has to be between 1 and 10. And I'm a big fan of my templates here, okay? First thing I do, I need to get the number 1,000 into a number between 1 and 10. Well, how do I do that? The number 1,000 is not between 1 and 10, it's 1,000. So the way I do that is I need to place my decimal. If I place it here, the number is 100. If I place it here, the number is 10. But here's the deal. It's a little bit more than that. It has to be bigger than 1, but less than 10. Okay? So it has to be bigger than 1, but less than 10. So again, rules. So it can't just be 10. Okay. So, oh no. Okay. I have to just erase, sorry. There we go. And I think, hang on one second, bigger than or equal to 1, but it has to be less than 10. All right, so if I place my decimal here, it is equal to 1, which is allowed because it has to be bigger than or equal to 1, but less than 10. So that's where I leave it. Now, originally, if the number is 1,000, I started with my decimal right there, okay? So my number now is 1.000 because that's what I have. And I have times 10. And I have this little box because that's what it looks like. That's what my scientific notation template looks like. And then I just have to figure out what goes in that box. Well, what goes in that box is how many places I had to move to get there. I went from the X to the decimal. So 1, 2, 3. So I put 3 here. And because I started with a big number, it's positive. The other way you can remember it is if you're going to the left, it's actually positive, and if you're going to the right, it's actually negative. Okay, so let's try number 2. Where do we put our decimal? Well, we put it right here because if we put it right there, we get 1.7. Okay, our decimal originally was right here because that's at the end of our number. And there's no secret to that. If there is no decimal in the problem, it's at the end of our number. So we have 1.7. Now, do we have to write all those zeros at the end? Absolutely not. So our scientific notation problem can look like this. The same as the one over here really could look like that, 1 times 10 to the third. Okay? But you can have that 1.000. But the whole point of scientific notation is shorthand. It's to make your life easier. It's to make you write less. So if you want to just write 1 or 1.7 and drop those zeros, you are allowed, as long as there's zeros at the end. So 1.7 times 10 to the what? How many times did we have to move this decimal? 1, 2, 3, 4. And because we started with a big number, okay, it's a positive number. So let's try the next one. We're going to place our decimal right here because we want a number that's in between essentially 1 and 10. Well, if we place it here, we get 4.38. So 4.38 times 10 to the what? Our decimal was here, so how many places would we need to move it? 1, 2, 3, 4, 5, 6, 7. And again, because we start with a big number, it's a positive. All right, let's do this one. We're going to place our decimal right here and get 2.26 times 10 to the what? Our decimal was here, so how many places would we need to move it? 1, 2, 3, 4, 5, 6, 7, 8. Big number, that's 226 million. That's obviously a big number, okay, a very large number, so it's to the 8th power positive. All right, so now look, now we have some of these small numbers, and they're obviously small because they're 0.8 or 0.00. They're below 1, okay? So in order to get it to be, again, we need it to be bigger than 1. So I would need it to be here, 8.23. So 8.23 times 10 to the what? Well, how many times would I have to move it? I'd need to move it from here to here. So that's 1. But now notice it's going to be -1 because I started with a small number. So since I started with a small number, okay, a decimal number, I'm going to, a decimal number under 1, okay, because these could have had decimals, but it's a decimal number under 1, I am going to be a negative exponent. All right, so here, I need to be between 1 and 10, so I'm going to put here 4.67 times 10 to the what? How many times do I move the decimal? 1, 2, 3. So it's -3 because I started small. All right. Next one, I'm going to put it here because I want to be 7.264 times 10 to the what? Now notice I can't drop any of the numbers past the decimal. The only ones I can drop are the zeros in front of it. This is the one time you can drop the zeros in front of it because, again, you want a number. You want the number between 1 and 10. How many times did I need to move the decimal? 1, 2. So it's -2 because I started with a small number. Where do I need my decimal here? Between the 5 and the 2 to make 5.2637 times 10 to the what? How many times did I move the decimal? 1, 2, 3, 4. -4 because I'm a small number. Need to put it between the 8 and the 2 for 8.26374 times 10 to the what? How many times did I move my decimal? 1, 2, 3, 4, 5. It's -5 because I am moving it in the right direction, starting with a small number under 1. Number 10, putting it between the 2 and the 3 for 2.3146 times 10 to the what? Moving the decimal 1, 2, -2 because I'm starting with that small number under 1. All right, look at, why isn't it letting me zoom? Ah, there we go. All right, looking at converting to standard notation. I know that if I have a positive exponent, I told you that I'm going to have a big number, yes? So positive exponent, big number. Negative exponent, small number. Okay, and by small number I mean decimal. So big number, I'm going to move to the right. Small number, I'm going to move to the left. And it's that many places. So if I am starting with 1. Change my color, sorry. 1.7, and I'm moving it 6 times. 1, 2, 3, 4, 5, 6. I fill in with zeros. 1, 2, 3, 4, 5. Notice you do not add the amount of zeros as the exponent numbers. You move the decimal, the number of the exponent, then you add just the amount of zeros that you need to fill in the spaces that you would need, right? So my answer is 170000, and remember we put commas every 3 starting from the right. So 1, 2, 3, comma, 1, 2, 3, comma. So the answer is 1,700,000. Number 12, we have this -5, so I have 9. Now 9, remember where the decimal is. The decimal is here after the number. So if we're moving 5 and it's negative, that means we're moving to the left. So I have to basically get like the 9 out of the way. So I have to move 1, 2, 3, 4, 5, and my decimal will be here. If I fill in the zeros, my answer ends up being 0.00009. So it's 4 zeros and then a 9. All right, so I have 7 point, and then I'm moving it 12 to the right. Okay, notice again where the decimal is. The decimal always goes after your number if it's not there. And then I'm moving 12 to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one does end up getting 12 zeros. And you put your commas every 3, okay? And it's a big number right there. All right, so this one, we have 2.88. Our decimal's already there, and we're moving 9 to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, because the decimal had to bounce in front of the 2, we end up with 8 zeros. And then the 2, 8, 8. All right. For this one, we have 4.75. We're moving 3 to the left. So we end up with the 2 zeros in front of the 475. So 0.00475. For this one, we have 3.2. We're moving 5 to the left. For this one, we have 4 zeros in front of the 3, 2. For this one, 17, we're moving 5 to the right. Because we have this 9 and the 3, we're actually moving 1, 2, 3, 4, 5. We have 3 gaps to fill in, so we get 4, 9, 3, 0, 0, 0. Moving to put the commas in from the right every 3, we have 493,000. For this one, we put the 6 down and the period or the decimal after the 6. We're moving 3 to the left. So 1, 2, 3. So we get 0.006. We're moving 5 to the right for number 19. So we have 4 point, and then we're moving 5 to the right. So we get 4,000,000, which ends up being 400,000. And then for number 20, we're moving 7 to the right, 5.735. 7 to the right is going to be 1, 2, 3, just to get out behind the number, 4, 5, 6, 7. So we're adding 1, 2, 3, 4 zeros. So we get 5, 7, 3, 5, 0, 0, 0, 0. We place our commas and we get 57,350,000. All right, so that was a review of scientific notation. This is one of those things where you are better off memorizing big number, positive exponent, little number, negative exponent, decimal, and that, you know, if you kind of get those things, you'll be better off. Let me know if you have any questions, and I will see you guys soon.